Well, it is time for part 2 of our hands-on coding workshop with Dr. Rachael Tatman, a data scientist at Kaggle who earned her PhD in linguistics at the University of Washington. We'll continue covering how to go from a model trained in a notebook to a custom API with full documentation. Rachael will show you how to create a super fast custom NER-like model in Python to use as an example, but you can also use your own project. Fun fact, do you know she has a hedgehog named Gustav? Rachael, the floor is yours.
Thanks, Addison. Hello, everybody. Good morning or good evening, wherever you are. So yesterday we talked about what APIs are, what REST is. There's some really good comments in the comments of the notebook. If you want to go take a look and join in. Somebody offered some really good suggestions for testing frameworks, which we're not going to talk a whole lot about, but if you're interested, good place to start. So yesterday we designed our API. We decided what methods we were going to have. We didn't design any resources because we don't have a database backend, so all of our data is going to be ephemeral. And today we're actually going to take our Python code that develops and then serves our model and show you how to, well, I'm going to show you, and then we're going to do it together, how to actually put that code into the Flask app. And I got a lot of questions about this yesterday, like, okay, so we've designed our app. How does it go together? How do I make my model actually do things? And that's what we're going to talk about today. So the two things we're going to do is first we're going to prepare our code to be served through an app. If you guys are like me, when you're just working in notebooks and getting stuff working, things can get a little spaghetti-like. If you've ever heard of spaghetti code where stuff just goes everywhere. At an early stage of the work process, I think we all tend to be there. So we're going to spend some time getting our code ready. We're going to do some modularization. We're going to make sure stuff is in functions and all wrapped up nice and pretty. And also, I'm going to talk about how to save a trained model as an object to use in other places and some pitfalls there. And it's also some good practices. And then we're going to write some of the code for our Flask app. And we're not actually going to write, I'm trying to unselect. We're not actually going to write the whole app today because the specific file structure and file names that you need in your particular app are going to depend on what you're using to serve it. So whether you're using Heroku or GCP, and we will talk, GCP is Google Cloud Platform, and we're going to talk more about that tomorrow. So I'll have an example where you can take the code that you wrote today and sort of plug it into the right place and then serve it, and you'll have an API that works. So my general principle when I'm getting something ready to be put into an API is first I want to make sure my code works. So this is sort of the, futzing exploratory stage, making sure that I can do the thing that I want to do with my code. And then I spend some time making it pretty. So this is when you'll refactor. If you haven't been writing comments as you make it work, you'll probably add comments here. I like to make sure that I have my little chunks of code that I want to reuse to make sure that they're in function. So it's not just a flat script that all runs. And finally, making it portable. And the bulk of what I'm going to be talking about here today is how to save your models as an object, some differences between different file formats, and then I'll point you towards some documentation for particular libraries. Ooh. One sec, have a little bit of tea. I could use the caffeine. Okay. So my example project I mentioned, I am getting a list of all of the Python package names in a piece of text. And this is a question I get pretty often. People will be like, I want all the people's names in my text. I want all the street names in my text. I want all the companies that are mentioned in my text. And the general task of locating and then tagging entities, so people, places, or things in NLP, natural language processing, is named entity recognition, or NER. We're doing kind of a lighter version of NER today. We're just finding instances from a word that exists in our list of keywords and then where they are in the text. The reason that I'm doing this rather than full NER, full NER takes a while to train, and B, you actually need to have training data already for your text with the identity and then the location in the character index, and then also the entity label. So is it a R package? Is it a Python package? In order to train an NER system using something like Spacey. So the thing we're doing today would be the first step of training custom NER. And if you don't actually need full-on NER for your project, which most people don't usually, depending on what you're doing and your other NLP things that you're applying, this might be all you need. So a nice, helpful thing. So my general workflow for what I'm doing is first I'm getting a list of Python packages, and we're gonna repeat this process, and I'm gonna walk you through it with our packages. And then I'm going to use a list to create a keyword processor object. This is from the Flash text package. If you are trying to extract keywords from text, I would highly recommend using Flash text over using regular expressions, especially if you have a list of terms and a list of documents and you're going to loop through a list of terms, look in each document, loop through a list of terms, look in each document. That's very time inefficient. And Flash text is much, much, much faster. So maybe 20 to 30 times faster in the best case scenario. And also you don't have to write regular expressions, and you don't have to make sure that the regular expressions that you wrote mean what you think they mean. Because if you worked with regular expressions in Perl a lot, you know it's hard to read, right? It's difficult to understand what the regular expressions are saying. And then we're also removing very common words. So the data that I'm working on is the Kaggle forums. So I want to remove common English words that people might just use on the forum. So for example, there's a Python package called the. I don't think every time people say the on the forums, they're talking about the Python package. And I'm also removing words that are used a lot on Kaggle, like Kaggle. There's a Python package Kaggle, but I don't think every time people say Kaggle on the Kaggle forums, they mean the Python package Kaggle. So this will just make our final output a little bit more relevant for what we're looking for. And then I'm doing a little test. So to walk you through my code, the first thing that you might notice is that it's all sort of flat. I've just imported stuff. I'm creating objects. I don't have any functions. I don't have any classes. I've just sort of like written a script. And we start by importing the things that we need. I am reading in the forum posts, so I'm using the meta Kaggle dataset here, which is our public dataset of the data on Kaggle, so you're free to follow along with this. And then I'm getting just 3 of our forum posts just for me to play around with. And then I'm getting information about the top 5,000 PyPI packages from the last 30 days from this URL, which is helpfully maintained by Hugo VK on GitHub. So thanks, Hugo. And to do this, I am going to need a internet connection. So if you're forking this kernel and you're working with it, you want to make sure that you turn on the internet connection. And then I'm taking a little bit of time to parse it, because what I got back from the internet connection was just a JSON item, and I don't need all of that information. All that I need are the names of the packages. So I'm going through each data item, and I'm just getting out the project, which is what the package name is stored under in this particular JSON item. And then I'm creating a keyword processor. So this is an object from Flash text that will let us find keywords. And it's actually sort of an interesting algorithm if you're interested in algorithms to go and take a peek at. But you don't have to know how it works. You just know that it does. And we're adding all of our keywords, and then we're removing some of those stop words I mentioned. So stop words are very common words like the, and I've gotten this stopwords.words from NLTK, which is a natural language processing library. And then I'm removing some custom stop words. So HTTP, probably going to show up usually in links that people are sharing, and not necessarily when talking about the library. I was like, I'm going to get a tissue. I feel my nose starting to get. It is full-on allergy season here in Seattle, and hasn't bothered me in the past, but it's starting to this year. So we have our processor, and this is modified in place. So these functions are just removing them from my existing object. I don't need to give this a new name. And then finally, we loop through our 3 sample posts and we apply it. So there's a Python package called Dataset, apparently, that people are talking about. Public, another dataset. Sorry, public is another Python package, HTML, events, common. And we might actually think that based on this, we should maybe be a little bit more aggressive in our data cleaning and removing stop words, because I don't think Dataset in all of these instances is being used to refer to the Dataset package. So we might add these to our custom list of stop words that we want to remove. But it works. So there's still time, there's a place for fine tuning. You might want to do a little bit more data cleaning, a little bit more text pre-processing, but it does what I wanted it to do. And you can see that I have commented this just so you weren't just like, that's just a bunch of code, Rachel. I don't know what it's doing. I've never seen any of these functions before. So the next step is to make it pretty. And in this case, I'm going to make it pretty by taking the two big tasks that I'm doing, basically, and chunking them into functions. So hopefully those of you who are familiar with Python have made functions before. I have one function that creates a keyword processor. So it does everything that I did, but instead of me specifying these are the specific words I want to remove in the line of code that runs it, I'm writing a function where I can choose, every time I run the function, I can give it different input. So I have the list of terms. So in my example, this was the list of Python packages. I have a Boolean argument for whether or not I want to remove English stop words. If I wanted to be a little bit clearer, I could actually say English stop words, or maybe remove stop words and then true. And then if you do remove stop words, specify what language you want to remove. So that would be an option. And then I have a custom stop word list. So anything in here will be removed, and by default, it's empty. And this function will let me train a new keyword processor very, very quickly without having to specify every time, okay, I want to remove English stop words. Okay, I want to remove my custom stop word list. And I also have a function, and this is a pretty small function in this particular case, but if you have a larger project that you're working on, this might actually be much bigger. So this is a function that will apply our keyword processor. So I just give it a processor and some text and whether or not I want the span information, so the index span where the words occur, and it applies it. So this is a pretty small function, but if I were doing something like image processing and I wanted to make sure that I cropped, if I wanted to rotate the image or do something to the images before I applied my package, I might want to put that in this. I might want to add another function and then call that function from this function, depending on your particular pipeline. And then when it's time to write our app, I can just use this specific function to apply my model. And we'll see that in just a second. So now I am testing my functions, and the line wrap is a little weird. Let me zoom out a tiny bit so it's better. I'm testing my function. So I'm creating a keyword processor from a list of packages. I'm adding in some custom stop words that I want to remove. And I'm creating a new keyword processor object from that. And then I'm applying it. So I'm looping through my sample posts, I'm applying my keyword processor, and I'm actually saying I don't want span information. So you can see up here, we got the character indexes of the first and last character. And down here we don't, because I specified that I didn't, because I just want to make sure that that worked. And sure enough, it did. So I have taken my sort of flat code that was just like blah, 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 and I've given it a little bit more structure. So if someone was coming in and looking at this code for the first time, they'd be like, oh, you create a processor and then you apply it. So now that my code is gussied up and we've added some documentation for each of the functions, how do we make it portable? How do we take the same code and run it somewhere else? And how do we do that without having to retrain our keyword processor every time? So one thing that I just want to call out, somebody asked yesterday, can we use an API to train our models? You could, because of the way that we're doing this, where I'm having you guys actually host your, serve your API from a cloud service. If you are doing that and you are having people train models on that cloud service, there's a possibility that you're going to be charged for that compute, or at the very least, you're going to sort of run out of free compute and they'll shut down your API. So one way to avoid that would be to have authentication. So if someone wants to use your API, they have to like have credentials and have like a username and login. And I'm not talking about how to do that. And just because there is, that potential that you might, end up using more compute than you actually intended to, I'm going to encourage you not to include model training. So take a model that you've already trained and then just apply it using your API. So doing inference. Saving models in Python. So if you have a library that has a specific way to save out its trained models, I would recommend that you use that particular method. So TensorFlow and Keras both use model.saveWeights and model.loadWeights to save and load models. And these will save models as HDF5 files, which are hierarchical files. And the easy, kind of the only data structure that you can easily do this for in Python is arrays and NumPy-based things. For PyTorch, you can use torch.save and torch.load. This will save it as a pickle, so the things I talk about regarding pickles down here are relevant. XGBoost you can do model.dump model, model.load model, like GBM, model to string, and model from string. So you have different options, and if you're using a library, I would recommend using that library's infrastructure for downloading and uploading models, because it's probably going to be the easiest for you. But sometimes you're using a library that doesn't have a library-specific technique, like flash text, which is what we're using. So in general, the easiest way to save a Python object from one instance and then load it into another is using a pickle. So pickles are binary serialization, is a binary serialization format. It takes your Python object, creates it to a byte string, writes it to a byte string, and then you can shift that byte string around, and when you load it back into your Python session, it'll be an object. This is very portable, it's very handy, it's very powerful. There are some things to know about pickles. So one big one that especially for things like the difference between TensorFlow 1 and 2, for example. If there are major differences between the Python environment you use to create your pickle and the one where you're trying to read it, so you have a different version or subversion of Python, or you have a different version or subversion of your library, it might not load. The Python core team is doing a lot of work to try and make pickles more portable, but there's no guarantee that they're always going to work. So just be aware. And one way to get around this is to specify the version of each package and of Python that you want to use in your app in your requirements file. And we'll talk about that tomorrow. Another thing to know about pickles is they're not super secure. And if someone just sends you a pickle, I mean, if someone sends you a pickle in the mail, probably don't eat it. But if somebody sends you a pickle on the internet, don't open it, don't trust it. The data format is pretty easy to hack. And if you've pickled it yourself, it's probably fine, but just be aware that it's not necessarily the most secure data format. So I don't want to scare you off of using pickles, but I didn't know these things when I first started using serialization as a way to move models around. And I think it's good to know. So caveat emptor. Enter. Buyer beware, except you're not buying anything because it's open source. So how do we save things as a pickle? Well, first we're going to need to import pickle. And then pickle.dump is the syntax. So dump is the same that XGBoost uses. It's just sort of a, take everything and stick it down into your file system. You want to make sure that when you open the file that you want to save it as, to write it, you want to make sure that you can write, so W, and B lets you write to a binary. So because pickles are a binary serialization format, you need to write a binary file for them. So if you don't include the W or the B, it won't work. Once we've done that, if we check out our file system, so just list all the files in our current directory, you can see that we've got our notebook file, an output file that describes the things that we have created in our output, and then also a pickle. And this is the pickle that we just saved. It's our word processor object. And if we want to, we can re-upload it as a new object. So I can use pickle.load to open this file, and again, I want to read, and I want to read a binary file because pickles are a binary serialization, blah, blah, blah. I've said all that. And from there, we can try it out. So we can use our apply keyword processor function that we wrote, and our pickled model that we read back in, and I have a little test example here. So I like pandas, NumPy, and Seaborn, three Python packages. And once I apply my pickled and unpickled keyword processor to it, I get out that pandas, NumPy, and Seaborn are the 3 packages that are in this little span of text. To save your model, when you commit your notebook and you look at the notebook viewer like this, you'll have a little output tab, and that will have all of the files that you have written to your current working directory, that top level working directory. And from here, I can create a new kernel using this file. I can create a data set from one or more of the files that I've created for my output, or I can just download them. So that's probably the easiest way to get your files out of your kernels right now. Let's go back up. Let's go. So I'm anticipating that this is going to be the bulk of the work that you're going to do today. And I'm going to, once I've finished going through, I'm going to actually do some live coding and show you how I would do this for a second thing, which is instead of Python package names, R package names. So make it work, get it going. Maybe you have other code that you can use from like a school project or something. Make it pretty, refactor it, make sure that you have functions, make sure you've got a little bit of documentation and comments, and then make it portable. So read your models out in a portable format so that you can send them to another Python environment and then you can apply them. Okay, and we'll go back and do this after I'm done with the sort of chit chat. Second, Flask App. So we're actually writing like part of a Flask app today. We don't have everything. We're not actually going to be able to test this, and we wouldn't be able to test it in kernels anyway because of the way that kernels are set up. But we'll test it tomorrow. It'll work, I promise. It will hopefully work, I promise. And we're going to write 2 files, and each file I've put in a separate notebooks file. So imagine that this is a file, and that this is a file, and that they're saved separately. I just wanted to put them in a notebook so it would be easy for you guys to look at them. So we've got 2 files. We've got a serve.py file, and this has the guts of our Python code. This is where we define our function to apply our model. This is where we say how we're going to read in our model. If you have like a pre-processing option, so you wrote an endpoint where people can send a file of a particular format and get back a pre-processed file, you would put all of that, the guts, in here in the serve.py file. And then we have a second file that tells our API what's where and what to do. So our guts are going to look very familiar to you. We are importing just the keyword processor object from Flash Text and also Pickle. And we've defined a single function here that both loads in our model and also defines another function for applying that model. So when we call this function from our second file, which we'll give a name to in the future, it will load in our model into the current namespace. But it will also return this function that we can use to apply our model. And I have straight up borrowed this particular architecture from Guillaume William, sorry. And there's a nice blog post that talks about more details, but I thought it was an especially tidy way to do things. So that's what I'm using. Feel free to pick a different architecture if you've got a favorite. So we have all of this in a file called serve.py. In the same directory, we have this file that doesn't have a name yet, and we will give a name in the future. In this file, we'll import everything we need. You'll notice that we also import from serve, import get keywords.api. So serve is this file, and we're importing it as a module, and we are just importing this one function that we wrote. So if we had additional, like, I don't know what else you would have in here that wouldn't be a function, but if you had other stuff in here, it wouldn't import it. And you could also choose to import just the whole thing. Here I've commented out because in our current working directory, we don't have any file called serve.py in our notebook environment, so this isn't going to work. But once we move to a different environment, we can uncomment this. And as long as there is a file called serve.py that has the function get keywords API in it, this will run fine. I also don't have to actually import this because I've already defined this in, I've defined this function in the same current working environment that we're in. Then we're going to create an instance of Flask. You don't need to worry about this a whole bunch. The only thing you might need to change here is you might need to make a different name if you have a really complex app that has a lot of different modules that are working together. We're not doing that. This is a very minimal example. And then we're going to run this function, get keywords API. Remember that this will load our model into the local namespace. And it will also return a function, keywords API, because this function returns this function, functions and functions. And then finally, we're doing the meat of the app endpoints. So yesterday, we talked about how to define an app. We talked about the Open API specification, and I should have had this open in a different tab. I'm sorry about that. Let me just open it real quick. And if we look at the specification that we wrote yesterday, we have a single post method. Here we go. We have a single post method called /extract packages that takes in a JSON and returns a JSON. And this is where we're actually, I scrolled to the top for some reason. And this is where we're actually writing the code that will serve that method. So we have an extract /extract packages method that is a post method, right? This is the endpoint. And this is the type of method that it is. So post from here. And it has a single function. And when I send some data to here, it will, when I run this endpoint, it will run this function. So I'm not actually asking for data here. I am sending a request to get the JSON file that we're going to send in, because remember in our specification, we said we were going to send in a JSON file and get back a JSON file. I had a really good question about that. Why not send in like a dictionary and get back a dictionary? We don't necessarily know that whoever's using this app is using this API is going to be calling it from within Python. So if they're using it from Java and we send them a Python object, it's not going to work for them, and they'll probably be frustrated. And JSON files is a much more commonly used way to send data back and forth. And then we, once we've read in our input data, we apply our function to it. So this is just a JSON file. And then we save our output file. And then we dump our output file, which right now is, what does it return? I think this is a list. I think it returns a list, and we are converting that list to a JSON file because we said we were going to send a JSON file back. So we better send a JSON file back. And this is our response. So just like dumping to a pickle, you dump to a JSON. And then our response is a JSON file out. So this is where we do all the things that we promised to do when we wrote our specification. And that is pretty much the whole thing. So we're going to go back. I'm going to fork this notebook. I'm going to write a little bit more code that will do the same thing as we talked about here, but for R packages instead of Python packages, R like the language. If you're peeling off now, just a quick heads up, tomorrow we're going to be using GitHub, and we're either going to be using Heroku or Google Cloud, depending on your preference. If you're using Google Cloud, you also want to enable billing. That does require a credit card. I think I mentioned that. If you don't have a credit card or you don't want to use a credit card, I'd recommend using Heroku instead, and we will talk about both of them. So do not worry. Okay. Let's get to coding. So I am going to fork this. And if you'll remember yesterday when I was writing my own little API, I said that I was going to have two methods, extract packages Python and extract packages R. And I already have all the code to extract Python packages, so I'm going to write the code to extract R packages. So first, I want to get it working. And I'm just going to run these cells because they're going to do a lot of the imports that I want. Also, I'm creating a new keyword processor, right? I had one for Python. Now I want one for R. I wrote a function that'll do it for me. Haha, reusable code. Dry, don't repeat yourself. I can use this function to create my processor. And then I can save it as a pickle. The thing that I want to do is I need to get list of our packages, and I don't actually have a super good idea of how I'm going to do that. I spent a little bit of time searching, as you can see. Maybe you can see, there we go. So I have an HTML page here. I guess I could download this and then do some, cleaning, but it seems like there's probably a better way to do that. And then I also have a list of R packages here, but this is loading. Whatever. Anyway, so that's also an HTML file, and I would ideally like JSON, or even if I could have it as just like a flat text file, that would be ideal for me. Let's actually see if anyone's created a list of R packages. And I know the data searching part is maybe not the most exciting. Yes, but it only has packages that have data sets distributed with them. And this is something that I created. This is me. I wrote this. Or rather, I redistributed a data set that somebody else had collected under an appropriate license. What if I search for CRAN? Maybe someone's uploaded information there. CRAN is an R repository of packages. Nope. And I remember that one of these that I was looking at had an API, but it looked like maybe the API didn't work. So And this is where I would usually turn to the chat, but I don't actually see the chat right now. And packages JSON. Oh, it's going to tell me about all of the packages that talk about JSON. That's not actually what I want. I know that there's a super easy way to do this in R. Get list of CRAN packages. So what I might do is I might actually start a new kernel. I might start a new kernel. It's available.packages in utils. So that's a base R file. Yeah, let's do this the dumb way. Hacking. All right, start a new kernel. New kernel, start a notebook. And I want it to be R instead of Python. I'm going to call this get list of R packages. Have a little sip of tea while this is loading. All right. And the only thing I want to do is packages. And I don't need to load in the utils library because that's that is built into R. It's in base R. And then I'm going to check out the head of that when I get it. And the reason that I want to know about both R packages and Python packages and why I want to extract them with two different methods is if I'm going on to other types of NER, usually what you have is not just like which entities there are and where they are, but also like the type of entity it is. So I can use my Python packages list to create training data to get to train a named entity recognizer that includes whatever the base named entity recognizer is, plus also Python packages. Sorry, I forgot what I was saying. And because I have a second function that will do that, I can use that to get additional information about R packages. So this was a good, I think this might actually be a very big query. All right, head packages. Oh, y'all, I forgot to turn on the internet. No wonder it was taking so long. It was just like making requests and like, is anyone there? No, sure? Yes. So this should work better. I should be able to actually get the list of packages. It might still take a bit because this is a big file. Oh, much faster. There we go. And then let's save this as a CSV. So I think it's filed.write. Maybe it's right to file. Yeah, I think it's right CSV. Packages and just call it R packages.csv. All right, that works. And then let's commit this really quickly. So this will create a new data set. Sorry, not a new data set. It will create new files. But the thing that I am interested in is it will create a file that we can use. And let's just super quickly, just to make my life easier, let's create a data set from this. So new data set, and let's call this list of R packages. And create, and then I'll make it public so you guys can check it out if you want. And if you are doing some sort of scraping, this could be the way that, so to get like a list of things you're interested in, so maybe you're having, maybe you want a list of all of the first names in the US and you're using census data, and you have sort of a, let's make this public really quick so you guys can check it out. I know this isn't the prettiest data set, but oh well. Whamp, whamp. Okay, so now we can add this into here. So we're gonna add a data set. And our data set is going to be called R packages. Is that what I called it? List of R packages. That should be enough to get it. There we go, and we're gonna add it. 2 people have looked at it. You guys are fast. All right, so now I can use this data to create my new object. Loading, loading, loading. So when we add new data, we have to restart the virtual machine, which is why it takes like a tiny bit. As you can see, 1/3 of a second. All right, your code isn't committed. Okay, yes, I need that. All right, so here is my work, a list of our packages. And I think we've already read in pandas. Let's just run our code and see if it works. pd.read, right? pd.read just read. And then the file path, and I'm hitting tab here, list of our packages, packages.csv. Nope. And just to make my life easier, I'm just going to run all the cells above my current cell. And then when I run this, it should work fine. All right, excellent. No error. So we've read it in. Now we want to take a column of that CSV and make it a list. Oh, I know this off of the top of the head, what columns of data frames are in R data structures wise, but I don't know it off the top of my head for Python. Actually, let's just see if our function will work. What was our function called? Let's just see if our function will work if we just give it the column. Our columns lists. I'm about to find out. So it's create keyword processor, and we're going to give it our packages and just see if it works. Our processor. That's not a very informative name, but I'll fix it later. Right now I am. Did I not run this cell? Thought for sure I did. All right. Oh, you know what? I bet there was an error up here. Yep. That's why I didn't run all the way to the bottom. There was an error because we've added a second file. So there we go. That'll work. Yeah. Okay. Now we're getting them good results out. All right. So the reason that didn't work is because when I added a second file, we append the name of the package into the name of the data set into the file path, so you can disambiguate between them. And I didn't. I forgot to update it. All right, does not work. Keyword list should be a list, so that is helpful. Oh, right. I just wanted the particular file, which I believe is called package. I know you guys are probably all in the comments like, here's the code that works, Rachel. Oh, beans. Sorry, I moved the cell instead of creating a new cell. I keep doing that. It's because we moved the button. Okay. This is an object. How can I create a list from a Python object? Pandas column to list. Get list from pandas data frame column. I'm not the first person to ask this. So it is list df1. All right. So list data frame, and then the specific row that we want is packages. Okay, so this should work. Famous last words. I've just given it the wrong data structure. It was looking for a list, and I gave it a series. That looks like it works, fellows. I don't know why I said fellows. It's a weird thing to say. All right, and let's give this a little testaroonie. So I'm just taking the tiny little thing I got up there for that sample post, and oh, right. I was like, it gives me exactly the same output. That's weird. It's because I'm using the old processor and not the new processor. All right, this looks good. So we're seeing information, prediction, robust events, a comparison, Johnson. Apparently there's a package called Johnson, archive, org. That seems like 3 links, huh? That seems like 3 links in that post that we have cited are all package names. And network. It works. Is it the world's most beautiful No, we could probably actually do a little bit of additional cleaning, but I am not going to live. And if you guys are interested in doing more cleaning and removing extraneous words from the processor, feel free. Make it pretty. I don't think I actually have to do anything here because I'm basically expanding on my earlier project. Remember that I had a process to I created my processor and I wrote a function to do that. And I applied my processor and I wrote a function to do that. And I can just reuse both of those functions. I don't have to futz with them. I can just use the codes that I wrote earlier. So modular code, reusable code, best practices. Already did it. But if you were doing something else, you were doing maybe image preprocessing, which I keep using as my example, then you do it there. And finally, make it portable. I want to save out my file, my R file, as a pickle. And I've already imported pickle, so pickle.dump. And then the object that I want to dump is the R processor. And I want to put it into a file. And let's call this R processor again .pkl, which is the I'm like 80. The more I think about it, the less I'm sure that that is actually what the correct file extension is. Well, that's the file extension I'm using for pickle. 80, 85. The more I think about it, the more sure I am. You can find that online. And then I'm writing a file, and I'm writing a binary file. And then I'm just going to quickly peek in my working directory to make sure it's there. I did not actually import pickle above. Hey, so we've saved our file. If I wanted to, I could read it back in, reapply it, make sure it works. I have a lot of faith here. Okay, what do I do now? So I'm going to write my Flask app, and I'm actually going to copy and paste this. And I'm going to do some a little bit of change, because remember that yesterday when I was writing my specific thingadoogle, what was it called? My open API specification for the app that I was going to write, it was the same as the example, except I added a new function called, so it was, I believe it was called extract packages _ Python and extract packages _ R were my two functions. And this is where I would go back and check my other specification. But I'm not going to do that because I'm lazy, but you should do it. I want to make sure I have time to answer questions at the end. So what I'm going to do is I'm going to take my existing function, and I'm going to call this Python. And then I'm going to copy it, and I'm going to create a second function that does pretty much the same thing, except I'm going to call it R. And instead of processor.pkl, which we're assuming we still have in our current working directory, I'm going to have it look for R _ processor.pkl. R _ processor.pkl. And I don't actually need to change the specific, what's that called? I don't actually need to change the name of the function. So here we have a function keywords API, here we have a function keywords API, but when we read it into our Flask app down here, what I can do is I can specify that this one is R, this one is Python, and then get the, well, let me do this real quick, Python and R, and then ask for the correct, get keywords Python, and then ask for the correct function that I defined above. So these will have different names, even though the underlying function that we defined in the function has the same name. And you could change it if you wanted, but I don't see the need. Yeah, I don't see the need. Because it's disambiguated because it's sort of tucked into another thing that has a different name. All right, and I said that it was extract packages _ Python. And I want to make sure that when I'm requesting the keywords API, I'm requesting the right one and not the R one. So this is the Python version. And we're going to add a new, so if you'll remember from yesterday, we added a post method for the R packages as well. Make sure that we have the right function name. Make sure down here we are calling the correct. Actually, will this run into problems? Sorry, I'm second guessing myself. Because in both cases, we are loading into our local namespace something called keyword_processor. And I think that whichever one we load in second will overwrite the first one. So I am actually going to make sure that this one is Python and this one is R, because we have two separate models here. And we want to make sure that we are applying the right model. All right. Yeah. Sorry, I'm thinking this through. So we're defining one function. It's being run on the input data. And by default, it is using this keyword processor. So we should give them different names. Yeah, okay. Sorry, I'm just thinking it through aloud so that you can see the process. And let's, yeah. Because previously I only had the one, and then we want to make sure that we return the correct function. Previously I had just the one function, so it was a little bit simpler. Now I have a second one that's a little bit more complex. And I could probably sit down and spend some more time refactoring this, maybe busting out this function and finding another way to define it with different. I don't know that I want a function that defines a function that defines a function, though. Anyway, I can spend some more time working with it later on with our app, just the same as with our initial code. And we'll make it work first, and then we can spend some more time making it pretty. So that is what we're doing today. Tomorrow, we're going to take the code that we've written here for our model. So reading in our model, which we've trained and we've saved out today. And then also the Flask app that actually applies that model. We will talk about the file structure that you want to have for both Heroku and Google Cloud. Each service has like specific assumptions about what's going to be in your files and what those files will be named and where they'll be. So we'll talk about that just so it works. And I'll give you guys a little skeleton that you can fork and then update. And then we'll get our apps running and you'll be able to query your APIs. And that will be very exciting. I'm looking forward to it. All right, I got about 10 minutes for questions. So I think Jessica is handling questions. Or possibly Addison, since that's who I see right now.
Right. Hey, Rachel.
Hey, Addison.
A couple questions. Actually, we only have about 5 minutes because we're preparing for our next session here in just a moment. But I think we might be able to squeeze in 2 here. First one from Bassem Tawfik. This came yesterday right after the end of your first session, which was, is API suitable for dynamic programming optimization problems, or is it meant only to access pre-trained models?
Yeah, so I talked about that a little bit. I think that absolutely you could do that with an API. I wouldn't recommend doing that with an API specifically for what we're doing now, just because I'm worried that you might get saddled with compute costs that you weren't expecting. But yes, I'm also not the best person to ask about optimization problems because it's not an area of my expertise.
No, totally understood. And actually, since we're already done presenting, you can go ahead and stop sharing your screen.
Oh yeah, of course. Sorry. You don't want to stare at my beautiful function.
We've been having people discuss in the chat all about some of them stuck with you with Python, but lost you with the R and vice versa. So maybe they do need a little bit extra of it. And then the next question here is from Deepak Mittal. Why do you use Flask instead of Django?
That is an excellent question. So for those of you who aren't familiar, there's a couple of app building frameworks in Python. Flask and Django are probably the two most commonly used. Django is a little bit more fully featured. It has a really simple way of adding authentication and dealing with other things like that. Flask is a little bit more streamlined. There's fewer things to do. It's smaller. You have to like build more things yourself. So I guess like Flask would be like Legos and Django would be like Playmobil, whereas sort of like in terms of friendliness of getting to the point where you have a house you can put dolls in.
That's how I understand it. I appreciate that metaphor.
Yeah, the reason that I picked Flask is because the minimal example of a Django app is just bigger. There's more code to look at, and I wanted to have the simplest possible example for people to look at. Because the first time I started writing an app, I was completely overwhelmed. There were like 80 files. There were so many nested subdirectories. I didn't know what anything did, and I found it personally really scary. So I picked Flask just because it's a little bit more bite-sized, but I have nothing against Django.
All right. Actually, we just had one more come in here right under the wire, and then we'll let you go and head off to our next session. This came in from a Sriyam. I'm probably mispronouncing this. I apologize. Rangarajan, who said, "It's not clear about the scope of the package. So kernels, data sets, dependencies, and security. Does it move from a source like Kaggle to any destination, like OGC only? And what sort of is the security posture that this API supports?"
So we won't actually be serving anything from Kaggle. We're going to be serving it using a different service, either Heroku or Django, Heroku or GCP, sorry. They will handle some of the security. We're not doing any sort of authentication. Basically, we're going to take the code that we've written here and the models that we've trained on Kaggle and move completely off of Kaggle. So we won't be pretty much looking at Kaggle at all. And that's just because serving APIs is not something that Kaggle does. So more on that tomorrow is sort of my wishy-washy answer.
And a nice teaser for tomorrow. Rachel, thanks so much for the time. For all of you who may be tuning in live for the first time, Rachel's been kicking off all 3 of our days of CareerCon, finishing up tomorrow with a 1-hour-long API building workshop. Those of you who still have questions that you want to have answered, please feel free to again join our CareerCon Slack channel. We have individual channels for every session, and some of our session speakers have been able to step back in and answer those questions afterwards as well. So continue to ask your questions there. Rachel, thank you again for your time today. We'll actually see you later this afternoon. I know you're helping with the session this afternoon, so we'll see you there in just a bit. For the rest of you who are tuning in online, we'll be back in just about 5 minutes at the top of the hour with the session on how to get your first interview, even if you feel like you don't have a lot of connection. So we'll see you then in just a bit.